Hello everyone, my name is Paula Harrison and I'm Professor of Land and Water Modelling at the UK Centre for Ecology and Hydrology in Lancaster. My presentation's on a project funded through the Landscape Decisions Small Maths Core with the title of Explainable AI for UK Agricultural Land Use Decision Making. It's a joint project between UKCEH and Lancaster University, and it involves 4 other investigators, Chris Nemeth, Pete Atkinson, Sizang and Hongyan Chen. And collectively we cover expertise from land system science and different aspects of maths and stats, including space-time modelling and machine learning. So our project aims to explore and test the ability of AI techniques to learn complex spatial and temporal relationships from data sets of land use and factors that drive land use change. We're investigating methods for informing landscape decisions by deriving data-driven if-then rules through an explainable AI framework. And we started this work in December last year. The project's 12 months in duration, and so we're focusing on developing a proof of concept for the methodological development in 2 pilot regions. So we started working in the pilot region of Oxfordshire using 10-metre resolution data from the Careen land cover map. We've chosen Careen due to its consistency in its classification system over space and time. And the map and graphs in this slide summarise some of the observed land use transitions between 2006 and 2018. And here we can see that relatively there are more extensive land use changes for artificial surfaces, which is urban areas, and for the arable and pasture land use classes compared to others. But this is relatively, and overall the land use changes are not huge. In addition to processing the Careen data, we spent a lot of time searching and processing data sets on driving factors of land use change. So we first undertook a meta-analysis of the literature, which showed that climate, accessibility and neighbourhood variables were particularly important as key driving factors of land use change in previous studies. So based on this information, we've created a long list of driving factors, and we've categorised them into those that change relatively rapidly over time and those that only change very slowly, if at all, over time. And we've then selected a subset of driving factors as shown in the table in the slide, and we're using this for exploring the development of the AI method. And these include variables that are related to climate, topography, accessibility, socioeconomics and protected areas. And our current work is now moving towards the development of the explainable AI framework. The land use changes and the driving variables that I showed in previous slides are being fed into this framework for graph-based probabilistic association and uncertainty estimation. We've been investigating which patch sizes are most appropriate for capturing the spatial structures associated with different land use transitions using deep convolutional neural networks. And our initial findings, shown on the right hand side of the slide, show that a finer patch size of 50 metres worked best for transitions to urban, whilst larger patch size of 110 metres was suitable for transitions between different types of agricultural land uses. So our future work will focus on further investigating the ability of AI techniques to learn complex spatial and temporal relationships in the datasets. And then we'll use this information to develop a set of simple if-then rules. And this will enable us to move forwards towards our explainable AI framework. And we will aim to apply this framework in another pilot region that has different agricultural land uses to further test and refine it. This slide also includes our contacts, and you're welcome to contact us for any questions about the project, and we look forward to interacting with the other projects in the Landscape Decisions programme. Thank you.